Welcome to solverfy.
In this problem on the topic of kinetics of systems of particles, we are given a system of 3 particles with the masses given as well as the velocities and external forces. We want to find the mass center, the first and second derivatives of the mass center, the kinetic energy of the system T, the angular momentum, and the first derivative with respect to time of this angular momentum for this two-dimensional system. So firstly, to find the mass center, which is R, we know that this mass center R is defined as the sum of the product of the masses times their positions divided by the sum of all their masses. And so this is m times a distance of d along unit vector I plus 2m into 2d times j plus 4m times 1.5d times k. All of this divided by the sum of the masses m plus 2m plus 4m. So simplifying, we get this to be d over 7 into unit vector I plus 4 times unit vector j plus 6 times unit vector k. And so that's the position of the mass center of the system of particles. Next, we want to find the first derivative of this mass center r dot, and this is defined as the sum of mi ri dot over the sum of the masses. So this is equal to m into 2v j plus 2m into 3v k, where v is the velocity of the system, plus 4m into v I, all divided by 7m. And so calculating, this becomes v over 7. So this is essentially the velocity of the mass center of the system into 4i plus 2j plus 6k. And that's the first derivative of the mass center with respect to time, which is the velocity of the mass center of the system. The second derivative now of the mass center of the system, which is the acceleration of the mass center, is simply the sum of the forces acting on the system divided by the sum of all the masses. That's simply by Newton's second law. And this is the force F along unit vector k divided by 7 times m. So that's essentially the acceleration of the mass center of the system. Next, we want to find the kinetic energy of the system. The kinetic energy T is equal to the sum of the individual kinetic energies of each particle, which is a half mi vi squared. And so this is equal to a half into m times 2v all squared plus 2m into 3v all squared plus 4m into v squared, which gives us the kinetic energy of the system to be 13 mv squared. Now the angular momentum about point O is by definition the sum of the position vectors crossed with the momentum vectors of each particle, mi, so ri cross mi vi. And this is simply 2 mv times d times k plus 12 mv times d times I plus 6 mv times d times j. So simplifying, we get this to be mvd into 12i plus 6j plus 2k. And that's the angular momentum of our system of particles. Lastly, the time derivative of the moment of the angular momentum, ho dot, is equal to the sum of the moments about O. And this we can see is simply minus F, the only force acting on the particles, times d along unit vector j.